and inequalities. So if you notice, first of all, they have the property of equality for exponential functions. Basically, what it states is that if b to the x equals b to the y, so if your two bases are the same, your two exponents are the same. Okay? So if your two bases are the same, your two exponents have to be the same. And so if you look at the very first example I say solve 2 to the x equals 8 cubed. In order for us to equate the exponents, these numbers have to be the same, and currently they are not. So what I need to do is figure out how I can get the same base. Okay, so do we have any thoughts? What?
Can you multiply it?
What do you know about 8?
Can you take the third row?
8 is actually 2 cubed, isn't it? And then so really, if I want to write 8 cubed, couldn't that be the same thing? So all I did is replace 8 with 2 to the third power. So then now, what do I do with the two 3's? Multiply them, so I really get 2 to what power?
6, 8, 9.
The 9th?
I thought you were adding this. Oh, no, I can't say it. Sorry.
So then now what ends up happening, since my bases are the same, all I have to do is look at the exponents, and I know that x equals 9, and that is your answer. So your goal is going to be getting the same bases on each side. Okay? So let's go ahead and look at another one. 9 to the 2x minus 1 equals 3 to the 6x.
2x minus 1 in the exponent.
Yes, 2x minus 1 is the exponent. So now you look at your bases. You've got a 9 and a 3. So what would be a common base between those two? 3. So really I can write 9 as 3 squared. So I have 3 squared to the 2x minus 1 equals what? 3 to the 6x. So now I have a power to a power. So what do I do with the 2 and the 2x minus 1? I multiply them. And so the biggest thing you need to understand is that when you multiply, you have to distribute that 2 to each. So really, I get 3 to the 4x minus 2 equals 3 to what? The 6x. So then now you have the same basis, which means that you can just strictly look at the exponents. So my new exponential equation will be 4x minus 2 equals 6x. So this is just a basic equation that you've solved for years. And so what I need to do first is I need to get my x's together. So I'm going to go ahead and subtract 4x from each side. And when I do that, I get 2x on the right side. What do you get x to equal? Negative 1. Questions? Do we kind of understand how this works? Now obviously they're not all going to be kind of as straightforward as the ones we've been dealing with. Okay, I want you to go ahead and try this one for me. Okay, you try this one for me. Okay, so as I went around, I think the hardest part of the problem was finding out that 64 is actually 4 to the third power. Okay, and so we have 4 to the 2n minus 1 equals 4 cubed. Now what you could have done is written both of them as base 2. The problem with that is you're going to run the risk of making a mistake. I would try and keep it at base 4 if you could. And so then your equation is 2n minus 1 equals 3. When you solve that, you should get n to equal 2. Okay? So now we're going to talk about exponential growth and decay.
Yes, it does.
So exponential growth and decay, we've kind of talked about a little bit before. Basically, the formula is y equals a times b to the x power. Okay, a times b to the x. A is always your initial amount. and B is your rate of exponential growth. Now understand that that's usually how it looks. Okay, B is to the x power. It's not AB to the x. It's A times B to the x power. B is your rate of exponential growth, so it could be a 2, it could be a 3. If it'd be a 2, it would be doubling. 3 would be tripling. It could be a 1/2. Okay, and x is always time. All right. So we're going to go ahead and look at an example here. It says Kristen starts an experiment with 7,500 bacteria cells. After 4 hours, there are 23,000 cells. Write an exponential function that could be used to model the number of bacteria after X hours if the number of bacteria changes at the same rate. So first of all, our formula, y equals a times b to the x. Do I know what a is?
Yes.
What is it?
7,500.
7,500. I don't know what b is, so I'm just going to write that as b, okay, to the x power. So then now they tell me that after 4 hours there are 23,000 cells. So what I can do is I can plug 23,000 in for y, okay, equals 7,500 times b to the 4th power. So do you see what I've done? I've plugged in the 23,000 after 4 hours. I've utilized that piece of information. Now the reason why I did that is because now I can find what b equals. So to solve this, I'm going to divide by 7,500. So when I divide both sides by 7,500, what do you get? So go ahead and divide by 7,500. Tell me what you get on your calculator. What'd you get? Huh? 3.1. Now the question is, how do you solve something like that? Okay, well, how I solve something like that is I'm actually going to raise each side to the 1/4 power. So you've got your 3.1 or whatever number was in there. I want you to go ahead and raise that to the 1/4 power and then tell me what you get.
Would that be the same as taking the 4th root of it?
Yeah, the 4th root is the same thing. So you can either take the 4th root or just raise it to the 1/4 power, it doesn't matter. You'll get the same result. What does it come out to be? 1 point?
1.3.
1.326, somebody got? Let's see what we
Yes.
should have gotten. 3.1 to the 1.3269, so about 1.33. Okay, so let's go ahead and round that to 2 decimal places. So my equation is really y equals 7,500 times 1.33 to the x power. All I did is plug 1.33 in for b. Now on the next statement it says how many bacteria cells can be expected in the sample after 12 hours. So what do I do now to find that? Yep. Go ahead and plug 12 in for x. So really you should have 7,500 times 1.33 to the 12th power. So how many? What do we get?
22,000.
222,482.
I'm getting 229,763.
How do you type that down?
Okay, now this is what I basically did. I did not round this statement right here. I left that in the memory of the calculator. So if you take 1.33 to the 12th power, you should get 30.635,12746. Okay, if you take that then times 7,500, you get 229,763.
How do you type that down, Lise?
Okay,
To a certain value?
you're going to do 1.33 and then hit the y to the x
Yeah.
to the
I
12.
just
Oh,
didn't
I
take.
didn't
I
see
didn't
that.
take it times the 7,500.
Okay. All right, so let's go ahead and see what we have on the next one. This is compound interest. You need to get this formula down. Okay, compound interest, you need to get the formula down. Specifically, this one right here. Get that formula down. So now it says an investment account pays 4.2% annual interest, compounded monthly. If $2,500 is invested in this account, what will be the balance after 15 years? So let's go ahead and start. My formula, A equals, that's my final amount. P, what will P be in this problem?
25,000.
2,500, that is my starting amount. Remember that principal is my starting amount, times 1 plus R is your rate as a decimal.
4.2.
0.042. Because it is actually 4.2%. Remember with that percent, we need to move that decimal back 2 places. Divided by n, remember that's the number of times compounded per year. They say it's compounded monthly, which means 12. Okay, and then outside I have n on the first term, and then t is my time in years. So 15. Now I'm going to show you the easiest way to go through and solve these. The easiest way to go through and solve these is to focus on the parentheses first. So we need to go ahead and calculate this. So what you need to do is do 0.042 divided by 12 and then add 1. So all I want to know from you now is 0.042 divided by 12 plus 1. And what did you get?
1.0035.
1.003 what? 5. Okay, now the exponent is 12 times 15. What is 12 times 15? 180. So now the next step you're going to do is you're going to go ahead and calculate this. You will not multiply by 2,500 till the final step. 2,500 will be that will be the final step. So go ahead and calculate 1.0035 to the 180th power. When you get an answer, take that answer times 2,500. Okay? So what do I end up getting?
Yep.
4,000 what?
4,688.
4,688.87.
0.86. Well, I guess it's
7. So there you go. Okay. Biggest thing is just making sure that you show the steps. And you do not multiply until the very, very end. All right, so real quick, we're going to look at another one of those. Account balance after 20 years. If $100 is placed in an account that pays 1.2% interest compounded twice a month. So let's first of all start. A equals, what's my principal?
100.
100. Okay. 1 plus, what will be my rate?
0.012 over
0.012. Twice a month
over
means
24
24. Okay, my power will be 24
times 20.
times 20. So remember what I said, very first thing you're going to do, 0.012 divided by 24, add 1. And you should get 1 point what? 0.0005, is that what you had? And then what's 24 times 20?
480.
480. So go ahead, take that 1.0005 to the 480th power. Once you get an answer there, I would like you to go ahead and multiply it by 100.
0005.
That's what 0.012 divided by 24, and then add 1 is. So what did you get? $127.12. So you made $27 over 20 years. Okay, so yeah,
That's a lot.
so.
Is that real life?
Any more with the rates? Yes. So this is what you need to do on page 464. I need you to do 9 through 23. Okay, so page 464, 9 through 23. Quiz tomorrow.